are in listen-only mode.
Hello everyone, are you able to hear me clearly? Is my voice audible to all of you and the screen? Great, great, great. So today we are going to discuss something about pig and pig Latin. Do you have any questions before we move forward? Let me just remove the pig and pig Latin, remove the session number 5 from it. Okay, I'll just put pig and pig Latin. Spark is there in the training, Sanjay. All right. Do you have any questions before we go forward? Yes, Suresh, you can practice on MapReduce in the next week. No worries. And is there any relation on MR and PIG? So not much, not much. So even if you did not get the complete hang of MapReduce, still you will be able to understand pig and pig Latin, what we are going to start. It actually makes your life a little bit easier, but that does not mean that you do not learn pig and pig Latin. You will see time and again whenever we are optimizing our pig and pig Latin scripts. Whenever we are optimizing our pig Latin scripts, you will find it easier to 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 optimize your scripts if you have understanding of MapReduce paradigm. Okay, so this map, I mean, the general understanding of MapReduce is required here. All right. Okay, so all right. So Sarvana's question is, where is the delimiter for input split is defined? So you can, there are two ways. One is every input format provides you a set delimiter method, set methods on top of config or job config, and or you can simply say config.set and the variable name, the key name provided by the input format you can use for delimiter. Okay. In every example which we talked last time, there is an example on how to set the configs. Okay. So every input format you should consult with the documentation of the input format to understand how can you configure the input format for changing delimiter, changing other aspects, or say if there is an n-line input format, how do you configure how many lines it is going to consume. So you should consult the documentation of each individual input format. Okay. Did it make sense to you, Sarvana? All right, good. So, no other questions before we start? Okay. All right. So today we are going to discuss something called pig and pig Latin. All right. All right. So pig is an engine for executing data flows in parallel on Hadoop. Alright, or you can say that the usual exercise is what we were trying to do on MapReduce. Pig makes it possible to do it uh, to do it in a very simplified manner. You don't have to code much. Alright, and Pig provides you a language called Pig Latin, and Pig Latin have operators like SQL where you can join two data sets. Joining two data sets meaning doing the intersection like the way we were doing intersection in our vote count problem. So those kind of things can be done very easily by single line of script. Instead of writing so much of code, the way you must have realized by now that in case of Hadoop, you have to write a lot of code. Here you don't have to. Okay. So Pig Latin is more like SQL and it helps you solve most of the data flows issues. Okay. And so it also provides you the filter kind of mechanisms where you can filter the data sets. And it runs on Hadoop and makes use of both HDFS and MapReduce. So, all right. Now there is two questions. Let me address before we go forward. All right. All right. Is pig ETL equivalent? Yes, and sort of. You will understand this very well as you go through the script, what all facilities it provides. Then you will realize that it does a lot of work for you. ETL, those who are not aware about ETL, ETL stands for extract, transform, transform, and load. So whenever you have to transform, load the data, you use Big Latin as well as you use other tools. All right. There's a question from Savana that we did not cover join in MapReduce. Actually, the joins we have covered, and you have actually understood the joins with examples like vote count. Okay. All right. So there are two ways of joining. Okay. Let me, if you guys allow me, so let me just describe. It's not a big thing. Uh, it's not a big thing in joining two data sets. Let me just try to explain what we have already covered. Okay, so you have data set 1, okay, in which you have some ID and some values. Okay, you have data set 2 and you have some ID and some value. Okay, or you can say attributes. Okay, so you have first and then you have say attribute maybe, or let me call it name and salary. I think this will make much sense. So you have, let's say, two data sets. One is giving the person's name, another is giving person's salary. Okay. Now, if you have to join two data sets, okay, joining two data sets like this, you have to find, let's say, you want to find out name against salary. Okay. So if you have to join these two dataset 1 and dataset 2, basically it's straight away your map reduce the way you had done the you have done in our problem number last problem number on word count, where you put these two datasets into two separate files and use the MR to load this data and join on. Basically the key will be your ID. Okay, that's how almost every reduce side joins work. Okay, so the thing which we did in case of word count problem, we were doing reduce side joins. Now there is something called map side joins. Map side joins, okay, so join two data set where map gives out ID as the key, and input files are both dataset 1 comma dataset 2. Both of these two datasets are the input file. All right. Now this was the classic example of what we had done. The other example, which is more obvious, and few of you already suggested me, that load dataset 2 into memory, and and in the map side itself, okay, map side itself, look up, okay, look up each key of dataset 1 in dataset 2. Okay, so basically what we could do is load this dataset 2 into the memory, and then whenever we are encountering keys from dataset 1, we basically look up in the memory. So id equals to 1, we look up in the memory, okay, it's 100, and we give out the value as Sandeep 10. Okay, so this is good. This is called map side join. Okay, this is good only if dataset 2 is very small. If you're trying to join two datasets in which one of the datasets is small, which can fit into the memory, then you use this strategy of map side joins. There you don't require a reducer. Okay, no reduce phase. You can turn off the reduce phase as we have showed you earlier. Okay, so you load. One is that you concatenate these two files, and then in the map make the ID as the key, and then you, because then map reduce phase will bring, the reduce phase will bring the these the values for each ID as together, and so based on ID, it will automatically bring it. So that is, so this will require the reduce phase, because in the reduce phase only the values are sorted. But in the second case, where we are going for map side join, we will just use mapper no reducer. All right, and all we do is load the second data set in the memory and split it out. Make sense to you? No. So we will, okay, one more small bit I forgot. So there are two ways to, there are, okay, when I say load dataset 2 in memory, there are few things to note. How can you load? One is passing dataset 2 as parameter. Number two, a parameter in job config. Okay, you could pass it as a parameter in the job config itself if your data is really very small. Second, if the data is little bigger, you could also define a static variable hard coding basically. Okay, I'm showing you the possible options. Third is using a distributed cache. Okay, this distributed cache is provided to you as part of the config object. Okay, All right. So Vidya, you can drop me an email. I'll have a look at your code and then we can discuss it. All right. All right. Next is that if we have multiple, there is a question from Sanjay. If we have multiple data sets like country, religion, etc., we can load this in memory and use the master IDs for lookup. Yes. If these data sets are small, okay. And please note that when I say small, it should be below like 100 MB. Because in case of mappers, we do not dedicate too much of memory to the mappers. Okay. So map tasks generally have a restricted memory. So you should take care of that. All right. Because most of these there are multiple map tasks that keep running on the cluster. If you are in an organization, there will be multiple people who are running their map tasks, and if every map task is consuming something like 1 GB, then it won't be possible to run multiple tasks parallelly. And by definition, MapReduce jobs are used in the cases where in-memory computation is not really very much possible. Therefore, to if some map task is consuming too much of memory, the sysadmins generally consider that to be a bad code. Okay, and honestly, so we have to be very cautious in terms of how much memory we use, and we minimize the amount of memory we consume in the map task. Okay. So the first there is a case study which I have put it on the website, where if you go to the blog, so there was a digital advertising. Okay, let me just. Yeah, so here is this case study in which basically the main reason why we got stuck during production time, when we were trying to launch our product on the cluster, why it got stuck was because we were consuming too much memory on one node. Okay, so you have to be a little cautious when you are consuming memory. All right. So Anandita's question is, there should be at least a reducer for sure. Not really. Not really. You can turn off the reducer. So the output of mappers will directly go into the into the HDFS. All right. Sanjay's question is, these small data sets are get loaded on every data nodes. Yes, that's correct. Data node, I mean, I wouldn't say data nodes. Okay, I would call them, you can say either task tracker or node manager. Okay, or node manager slash application master, or container slash application master. So node manager has container has application master, map reduce application master. All right. So yeah, you can turn off the, if you don't, you can say straight away that we don't need map reducer, and that's it. It will consider your output. All right. Any other questions before we move forward? All right. So there is a good question. So here is a question from Lloyd. The question if we have a lot of small files and is it advisable to move these files into HDFS, okay, and then zip, or zip it before moving to HDFS? So the quick answer is before. All right. So a better style is basically, let me look at the specific API of ggp split table. So what people do is they create a zipped archive file which can be appended to at later point of time. Okay, so if you are expecting a lot of files addition into the HDFS, so what you do is you create a zip file archive and you can append to a zip file archive at a later point of time. This I need to have a look at it. Okay, as far as I have read, you should be appendable appendable zip file is very much possible. I need to just check it once. Is there a recommendation on the size of zip? uh, okay, so for HDFS, the file size doesn't really, I mean, there is no kind of upper limit on file size. Okay, because at the end of day HDFS breaks down into small files. Okay, so there is not a kind of a recommendation per se, at least I don't know of. All right. So Shravana's question is HDFS append is not, no, HDFS append is allowed, very much allowed. Okay. So if you see even our, let me just try to log in. Okay. Is this terminal font visible to you? So let me try to log in. Let me just see what is the, all right. Okay. So here, all right. So if you see Hadoop FS, okay. So do you see append to file? Yeah, so append to file is very much possible. So I'm just wondering that the ggp splittable files are appendable or not. That is something I need to look into. All right. Appendable zip file means, what is the meaning of appendable zip files? Appendable zip files means, can I append to an existing zip file without having to download, unzip, add file, and zip and upload. Instead of having to go through this cycle, can we keep on appending to the existing zip file? Okay. So that is what it means by appendable zip file. I need to have a look at this. All right. And so Vidya's question is, what does the header of zip file contains? Do the files in the zip be of the same type? Not really. Not really. So okay. So the header of zip file basically contains the information about the zip file, and it varies from one format to another. Algedo has and gzip splittable. Okay, gzip splittable are two different infos. Okay, so I need to check what exactly is there in their header. All right, and based on that only, I'll be able to deduce whether a zip file is appendable or not. All right, good, very good set of questions. Should we move with our big discussion? So even if you do not get a complete grip of MapReduce, still pig will make a lot of sense to you. Still you can use pig, and it's not MapReduce is not really a kind of prerequisite to start using pig. All right. Although while optimizing pig script, you can do optimization of pig script better if you understand the MapReduce paradigm. Good. All right. So basically, Pig runs on Hadoop and it makes use of both HDFS and MapReduce. So Pig also directly talks to HDFS. Say when you say select star from a file, and it doesn't require any maps and reduces, all it requires is to download a file and display it to the user. In those cases, Pig directly talks to HDFS and gets you the data. But in case there is a processing required of any kind, in case it requires any kind of processing, it would use MapReduce phase. So it will convert whatever queries you have into something like a MapReduce under the hood and get it done, and will give you the result. All right. So in a very quick way, the way we learn any programming is you generally go back and forth. You look at a sample code, you look at a hello world, and then you go back to the definition, back to the basics, and then come back and look at some more examples, try to execute them. And that is how you learn any programming script. All right. So here what we are saying is, so a pig construct looks like this generally. The comments, it starts with comments. You can put comments. Double dash is the comment, and I think slash star asterisk is multi-line comment, just like C++. You can, and every line creates a new data set. You can see that. So this line says load this file. Okay, and here is the data type we are imposing, which is optional, and load this file into dataset called input. And when we load, and after that we can iterate over one by one, As in, when we say iterate, it is more like select statement. We are basically going from top to bottom on the records. So for each input, generate, flatten, and the words. And once we have basically converted each line into one word per record, so that there is only one word in a row, then we can group by it and then count. So that is what our word count looks like in Pig script. It's hardly 6 7 lines. 1 2 3 4 5. So total number of 5 lines. Flatten is a function. Flatten is a function, and tokenize is a function. Tokenize breaks down line into array of words, and flatten converts that array into one word per record. All right, we will go into the details. Do not panic if you did not understand any of this. We will go into the details of each statement one by one. So that was a quick, really quick way of setting your expectation vaguely that this is what you will be able to do at the end of Pig Latin session. Okay, so this is what you will be able to do at the end of the session. Now, again, going back to the basics, Pig Latin helps you describe how the data is flowing, how the data should be read, how it should be processed, and how it is stored onto the multiple files in parallel maybe. Now, you can define complex workflows, and when you're defining complex workflows, you can get multiple inputs joined together, and you can split the data into multiple streams parallel. The things which are not possible in Pig are something like this. There are no ifs and no for loops. Okay, only iteration is there, where we are going for all records in. Okay, so do not confuse for each with the loop. Okay, it doesn't have a loop because it's not a programming language, it's a data flow language. All right, a quick comparison between Pig Latin and MapReduce. While Pig Latin provides you these constructs which are oriented towards data flow, such as joining two datasets, filtering a dataset and creating a new dataset, or group by, which basically groups the records based on one key to one particular parameter, order by, and then union, just like SQL. While MapReduce is a raw programming and provides group by and order by indirectly in the form of map and reduce. Okay, joins are really hard, as you must have noticed in our word count problem. Joins were not really obvious. In case of Pig Latin, it provides optimizations such as rebalancing the reducers, because Pig Latin internally is going to call MapReduce, and since Pig Latin knows more about your data, on it is able to take a guess on how many reducers it is able to take a guess on how many reducers are required. Same optimizations what Pig does for you automatically are difficult to do by yourself. Okay, you will see that in future. For example, the thing which we have just showed you, I was just discussing about map side joins and map reduce side joins. Those two cases, if you try to build it yourself, it will take a lot of time. While in Pig Latin, they have provided you as part of the language itself. Okay, and Pig Latin, since you describe that this is my data and it has these many columns, so it knows more about your data, just like SQL. While if you are writing a MapReduce code, it doesn't really know much about your data. So the your data is quite opaque towards MapReduce, and therefore MapReduce is more like a raw programming, while Pig Latin is good for data churning in general. Okay. So pig-Latin codes are 9 lines, while MapReduce codes are of 170 lines. And pig-Latin has got limitations. Say, there was a problem where we were trying to bring the people with D- mirror image of DNA together, same or mirror image of DNA together. Those kind of problems, solving those kind of problems are little tricky when it comes to pig Latin. We might have to create our own user defined functions, but still it is going to be little difficult. Similarly, building a tool like Scoop, where the data is it's getting its data from various various machines and pushing it into central was possible in MapReduce, but the same thing is not really possible using piglatin. Okay, so so all I'm trying to say is piglatin is great. You start with your problem and try to think in terms of piglatin, that okay, this is what I'm going to do. And in case at any point of time you realize that you cannot get your work done in piglatin, then you move ahead with MapReduce. Sounds good? And for that it's difficult. So it's difficult to do that, to figure out whether to use piglatin or MapReduce unless you know both. Okay? Unless you know at least piglatin. If you at least know piglatin, you will be able to say that okay, these are the things which I can get done in piglatin, and these are the things I cannot get done. Therefore, you might have to use MapReduce. Sounds good? So Sanjay's question is, can we take a raw MapReduce program and then auto convert it to piglatin and vice versa? Um, Taking a piglatin and converting it to my MapReduce is possible, but not the reverse. Okay, not the reverse. It will be really difficult because it's easy. Piglatin is a easier language than the core like Java program or something like that. Okay, therefore it's actually difficult to generate piglatin from MapReduce. Okay, it's like how should I explain? So if I'm given an assembly language, I cannot really generate the actual code, which we call disassembly. It's pretty difficult. But given any code, I can generate the assembly code. Okay. Make sense to you now? Alright. There are many use cases for piglatin, starting with ETL. ETL as in when you have to transform data and load it into database, then piglatin comes pretty handy because it's able to handle and parse the data which is not in the tabular format. Even if your data is not in tabular format, you can handle easily using pig. Okay, so if you have to do a research on data, analyzing whether what kind of data you have, pig is good because unlike SQL where you have to have data well defined, it doesn't need it. Okay, for defining and researching the data, you can use piglatin very well. And whenever you have to do iterative processing, then also you can use piglatin. All right. The core philosophy of pig is it eats anything. So any kind of data, whether relational, unstructured, or nested. Nested as in something like XML or something like JSON format, where one object can have other objects. So that is nested kind of data. So it's okay with any kind of data structure. It provides the construct to handle all kinds of data. So even if your data is in proper CSV format, the Pig is okay with it. If your data is in raw like plain text file like logs, it's okay with that. And you can load it and then start parsing it. Now Pig lives everywhere, meaning the objective of Pig is to be portable to any parallel computing environment or any distributed computing environment. That's the sole aim of Pig. And not only Hadoop. So, for example, they have started porting Pig onto the Spark. Third is pigs are domestic animals, as in they are controllable, provides custom functions in Java and Python, and custom load and store methods. Pigs fly, designed for performance. All right. So to install Pig, you basically also installing Pig is probably the more easiest thing to do. Reason being, Pig doesn't require any service. It's just a bunch of class, just bunch of client. It's just bunch of libraries which you can download, unzip and start running. Also, to run Pig, to install Pig, you don't require administrative privileges. You can just unzip anywhere and start using Pig. All right. And all you require is first you can download it. This is just optional. I'm moving the Pig to a common folder, and you can start using it. Set the Java home folder because it requires Java home variable so that it can run Java, because Pig is written in Java, so it requires JVM to launch the Pig prompt. So even if you do not have a Hadoop installation, you can start using Pig. And just like MR unit, which was able to run in isolation, it has a little simulator of Hadoop. In the same way, Pig comes with a small simulator, and I think it's the same MR unit one. All right. And so you can say pig minus x local to run it in a local mode, such that you don't have to install Pig on your local machine. Okay. And if it works, that means your Java is properly set and you have downloaded Pig correctly. Now, when you want to get things done on Hadoop, you can say, you can give it the class path of Hadoop folder. You can simply say pig underscore class path equals to etc Hadoop. And from there, it will automatically figure out where is a name node, where is a data node, where is HD, and where is node manager and everything, right? Lloyd's question is, can we install Pig on Windows? I think yes. I have not tried, but they say that it runs everywhere. It runs on Mac, it runs on Linux. I've tried both, but Windows I've not yet tried. Right? Also, the Pig is already installed on our everywhere, so you can basically say things like Hadoop. Okay, if not like this. In case you are facing a memory issue kind of thing, you try to log in onto other nodes, because Pig, since it's running a virtual machine, it consumes some amount of memory. Okay, so you can see here you can simply say Pig and it will start Pig. So this is grunt. This is the prompt of Pig. You can see the prompt. Just to test whether it's connected to our Hadoop or not, you can simply say ls. Okay, it'll show you the listing of files. And I use Pig's prompt frequently to interact with HDFS because it gives a far more easier way of interacting. If you have to upload, download, you can simply say copy from local, or you can simply say copy to local. All right. So this is the grunt. So Sanjay is saying, can we use Hadoop for non-Hadoop processing? Um, you can, but it doesn't make much sense. You have for non-Hadoop processing, you already have things like SQL, but yeah, you can definitely use. If you go for pig, let me show you. Let me show you. Exit. You can say Control D actually. Simply Control D and it will exit. Yeah. So here you could say pig minus x local. It'll run in the local mode. At the time, every command we do will be executed locally. If I say ls now, it is showing my local folder structure, not HDFS. Alright, you can see file, blah blah blah. These are local files, not the HDFS one. Make sense to you? What? Quit. It's quit. Alright, so this is how you can get started with Pig. So Lloyd's question is, can we call Linux commands in Pig? No. If you have to make a pipeline, what you can, I'll show you a few examples. If you want to combine the pig commands and Linux commands, you can do is call the pig on a particular command, and whatever is output you can pipeline from Linux. Probably that's what you want. All right. You can either SSH to any of our servers. Instead of this, you can the login. Okay, whatever is the login provided to on the here, it's Hadoop 17. Okay, and then you can start pig. All right. Voice lost for me. Is everybody able to hear? Because Sanjay had just lost the voice. Yeah. All right. So good question, Lloyd. So yeah, although it looks like that every command when we are saying, I said ls, so it looks like that Unix commands are working, but ls is actually the Hadoop HDFS command here. Okay. So if I have to say copy from local, I can say that. All right. I can say. You can see all these commands. All right. So pig minus x local is good for running pig commands without Hadoop installation. Very useful for testing locally and improves the development pace. And we can also also say what Shravana was saying, that there was, yeah, I missed the question. Yeah, we can use pig for we can use pig for non-Hadoop processing. Let me add it. Okay. All right. Yes, all fs commands can be executed. All right. Now you can other than usual way when we did not provide any argument and we got the command prompt, grunt prompt. Okay. So instead of that, you can also if you run a script, pig script. Pig script is nothing but bunch of commands, pig commands written in a file. Okay, just like any other script, it's just bunch of commands written in a file is what is called a pig script. So you can say pig and the script name and it'll get executed. Okay, or if you want to just execute a single command, you could do things like this. So ls is a single command that I'm trying to execute. Yeah, you can see that. So if I want to pipeline this data and want to grab something in it, say I'm trying to grab WC, then I can do that. So that's where you use this kind of a syntax. All right, you can see that it gave me only one record. Good. So the usual way is to interactively clean up the data or interactively talk to Hadoop by using the pig interactive way, which is grunt. This is where you will be typing all the commands. You can also control Hadoop from here the way I showed you the fs commands, ls, cat, all of those. Other than that, you can kill a job as well as you can execute or run an external pig script from inside of this prompt, which is very useful. Okay, so to interactively deal with pig, the grunt is the best possibility. The basic construction, again I'm going back to pig Latin. So basic construction is every processing step results in new set. Okay, let me put some exception here, except for dump and store. Store stores the data into a file and dump prints the data into the onto the screen. Pig is almost everything is case insensitive, just that the functions you define, they are case sensitive. If you have to put multi-line commands, you can start the commands with slash asterisk and then end it with asterisk slash. If there are single line commands, you can use dash dash, okay, for single line commands. Sounds good to you? All right. So let's try to do something like this. Let me go through where is my data. I have recently moved the data, so it may not be there. So, all right, I think data is there at this location. All right, let's just try to do, as I was telling you, that we'll keep on going back and forth with example and the basics. Let's try to do a simple thing. A simple thing is load this data and compute the average for each of the symbol. These are symbols. So we are trying to compute the average value of symbols. Okay. If you had to do it in MapReduce, in the reduce phase, the map will give out this as the key and reduce will basically compute the average, right? That's what you will do in the usual MapReduce, correct? Now, if you have to do the same thing here, you can say load my data. Here, these steps are redundant, as in these are just to investigate what is inside our our data set. So let's try to do this. Let's try to load our data. Okay, so we can say this, and also now let's check if there is something loaded in divs or not. So I'm saying dump, which is printing onto the screen, which is printing the data which our divs is pointing to. And if you notice, the moment we say dump, only then the processing start. There are multiple things to notice here. When we say load, it did not really do much. When we say load, it did not do anything at all. It just noted it down. But the moment we say dump, some action has happened. Okay? Some action has happened. And here, if you notice all these lines, they look exactly the way it looked when we executed our MapReduce job, right? You can see that it has provided us a URL to track what's going on with the job. Okay, if you go into the browser and see this, it shows you that there are map, but there are no reduce phase. So that's what it is doing. You can see that it has printed the data which is there. All right, now going forward, this is the first step. Next is let's group the data. When we say load the data, it loaded this particular file's data into this data set. As in loaded, as in it just noted it down. The real work happened when we said done. And we also are saying that this data inside this has got four columns in it. Name, ticker. We are giving the names to those columns. And please note that we are not providing any data type. It is trying to infer the data type by itself. Now next is we can simply say group. So it just grouped it. It did not aggregate it. Now we are saying for each of the groups, please generate the average. Okay. And let's just try to store our data in a in a folder called averaged. Okay. Let's just try to store the data in this folder. Now, if you notice, the moment we say store, only then the processing has started. Otherwise, it was just making notes of it. It was just making a note of it that what are the things, what are the steps you are trying to convey. And the moment you say store or dump, it started working. Yes, Shabna's question is data set here is input split in MapReduce. So yes, internally it's going to use Hadoop's input splits or input formats and are going to use that. Okay, I'll show you where is this file located. You can see it if you go to 8000, not 8080. Okay, so here you are. So if you I think I'm logged in as student. Let me try to log in as Hadoop 17. All right, let's try to go into slash. You can see the data folder here. And here is the NYSE dividends. So you can see that the data is tab separated. Okay, you can of course also load the data which is comma separated. And in the home folder, let's go to home folder. Because we did not specify the file starting with the slash, so it will create that into the home folder. So here there would be a folder called averaged. Yeah, here it is. So that it has stored the results into this file. Okay, you can see that the dynamics is exactly the way it happens in MapReduce. It created an output folder, and inside that part there is one part. So Sanjay's question is, these commands worked on entire data. If you want to process just part of the data, yes, we can do that. We can do sample, we can do limit. All right, we will show you that. So this was the basics of computing average of our values. Okay, sounds good to you? Now moving ahead, big as we are as we go ahead, there are values like when we say NYSE dividend, load it as name, ticker, date, and columns. This is our name, ticker, date, and value. All right. So we are not specifying the data types. If we have to specify the data types, we can specify these kinds of data types: int, long, float, double, char array, byte array. By default, it considers everything as byte array. Byte array, as in, it's basically consider it as a binary data. Okay, all right. So here, if you see there are, in general, there are two sets of data types. One is scalar, which are basics primitive data types: integer, long, float, double, char array, byte array. Char is string, char array is a string, and byte array is a binary array. Okay, for binary data. When you have no clue about what is the input data, you use byte array. Next is the complex data types. Complex data types are of three kinds in case of pig. One is map. Map means it is key and value, a collection of key value pair. All right. So the key can be a string or char array, while value can be another complex type or scalar. The other data type which is there is called tuple. Tuple is basically like a row in a database table. Tuple is a collection of values, an ordered collection of values. The tuple has got fixed length and is an ordered collection of values, is made up of fields and their values. Every value can be given a name or accessed by their index. Okay, so you can say that tuple is basically like an array, just that other than accessing the values by 0, 1, 2, you can also give them the name and access those values by the names. Okay, that's what it is, a tuple. Now there is a different kind of things called bag. So you might get confused between bag, tuple, and map. Map has got key for sure, okay, while tuple doesn't have any idea of a key, and it is just like an array, while bag is a collection, unordered collection of tuples. You can say that bag is an equivalent of dataset or database table. Like a database table is a collection of rows, here a bag is a collection of tuples. So every dataset by default is loaded as a bag. Okay. All right, a tuple can have the various data types, not just like our. If you try to take analogy with our usual arrays of C or Java, their individual all the values in an array are identical. In case of tuple, that's not the case. All right, and bag is an unordered collection of tuples. Two tuples, each with three fields, is displayed here. So you can see there are two tuples contained in a collection. Okay, so the way it is represented internally as well as the way it is passed are demonstrated here. So if you put your data in a file in this format and ask Pig to load it and tell that it's a map, it will automatically parse this data and load it. Alright. A bag does not need to fit into the memory. If it doesn't fit in the memory, it will spill over to the disk. Alright. Let me take your questions. You have any questions at this point? Okay, a complex tuple could be an example like this. It is a tuple where first value is a char array, second value is an integer, third value is a float, while fourth value is a map. The fourth value is a map, and and this is a map of two two key values where the key is first key is name and and first value of the key name is Bob, and the second key is age, and the value is 55. Okay, this is an example. Clear, Ravikant and Anandita? Is everyone with me? Great, great. So you will notice that Pig is a far more simpler to get your work done as compared to even SQL. So please pay attention, and trust me, it's going to be easier than what you thought. Okay, only these few slides are little difficult, rest are going to be far more easier for you. All right, now regarding data types and schemas, it's not very particular about schemas. All right, you could either say, when we loaded the data, you could either say things like this. Okay, you could say, let me try to show you actually whether it works or not. So you could say this, or you could say, all right, you could say things like completely without anything. Okay, or you could say things like partially, you are just telling the, okay, let me go step by step, that will be easier for all of us. All right, so when we are loading the data like New York Stock Exchange dividends, we could either define the column and the data types. Okay, so here we are saying exchange is a character array, symbol is a character array, date is a character array, and dividend is a float. Either we could say that, or we could just say that these are the columns we are talking about. And by default, whenever we say load, it is loading the data by tab separated. It expects this data to be separate, tab separated. If it is not, then everything will be loaded in a first column. Or you could simply say like this. So dividend will be, essentially this um, dividend will be a bag. Okay, bag of tuples of this type, these values. Okay, dividends will be a bag of these tuples. So Sanjay's question is, what is an ordered collection of values? Okay. So when I say ordered, here this is on order. We are saying that our tuple is going to be, our data is going to contain such rows which have these four values. Dividend is a collection of this kind of a row or this kind of a tuple. Each tuple has got first column and exchange, second as symbol, third as date, and fourth as dividend. We can later on we can say dividends, or we can say for each this, and then we can access it by either exchange or by zero. All right. When we say group dividends by, we'll see it later. When we try to address a particular column, we can say exchange, or we could say $0. So we are trying to address a particular column either by its name or by zero. And when you have this flexibility of ordering things by zero or one, it makes sense if they adhere to the order. If exchange will always be the zeroth column and symbol will be the first column and so on. All right, makes sense to you? So therefore, it's an ordered collection. Okay, no, order doesn't mean sorted. Order is just, we are saying that the way we are defining our columns, the order will remain consistent. Okay, unlike a map, unlike a hash map hash table you must have seen earlier. Okay, the order will be adhered to. All right. So you could either define schema upfront or you can completely skip the schema. It will try to make the best guess. It will try to guess the data types of various columns whenever required. Similarly, if you are declaring the complex data type, you could say simply like, if let's say I'm loading my data and I could simply say my exchange is like this, or I could say exchange is a map of values. All right. Or inside a map, I can go one step further and define the values, because in a map, the key is always going to be string. The value can be further a complex data type, or further map value could be a primitive data type. So I can go one step further and define even the data types of the values which are going to be inside a map. Okay, so just like this, here I'm saying A, where I'm not saying that A has got any data type, or I could say A colon map, meaning the the column called A, the field called A has got a data type of map. Or I could say A is a map of A is a map of key value pairs where the value is this. Value's data type is this. Okay. Map is a collection of key value pairs. What is the data type of the value inside this map is here. Because key is always going to be string. So you don't have to define the data type of key. Alright. Here I'm saying the key is string and the value is a tuple, and inside tuple what are the various data type of each field. So it is totally flexible in this sense. Similarly, in case of tuple, I can say that my field is either a tuple, and further I can go ahead and say give the name to the fields of the tuple, that first column is X and second column is Y, and I can go one step further. While loading the data, I can tell that this particular column is a tuple which contains two fields inside it, and first field is X, which is integer, second field is Y, which is a binary array, byte array. All right. Similar is the case with bag. Similar is the case with the bag. Here I'm saying, okay, my field which I'm trying to load from the file is a bag, or it's a bag containing the tuples whose data type is integer and integer. And can go further one step ahead here, saying our bag contains tuple of this data type. All right, or I can ignore the data types in it. So the point here I'm trying to make is pig is very flexible when it comes to the data types. You can cast data from one type to another, just like any C, C++, Java. We can cast the data type of one value into another by affixing brackets and the data type. So if I'm trying to cast a float into integer, I can put this, or I'm trying to parse a string into integer, I can put this, or I can say things like this. All right. Although it does almost everything by it guessing. Yes, Kanaga. It meant when I say ordered collection of column, it meant ordering of the columns. That's correct. Lakshman's question is, can you name the key? Can you name the key? So yes, you can name the key. I'm sorry, but so are you talking about in the map? So key doesn't have a name. Only the we can give the name only to the tuples. All right. Key doesn't have a name. We can only name tuples. Right? All right. So the initial one, which we have already covered multiple times, we could simply load the data like saying my divs equals to, okay, something like this. Okay. Here, please note that I'm putting slash. If you put slash, it means it is an absolute path. All right. We did make a mistake here. All right. Now, if we want to load a data which is relative, we could say things like this: avged. Okay, this is something which is contained in our folder. All right, there are two things we did just now. We where is our where is our yeah, let it finish. So you can see that it's basically a MapReduce job that's getting executed here. If you try to look at this URL, you will find that again here there is no reduce phase. It's only map phase. So it has loaded the data. And what did we say? We said we said something like this. And what is avged here? It is not starting with slash, therefore it is relative to my home folder, and my home folder is user Hadoop 17 in HDFS. And there it will try to look for this averaged folder. If it found a file with this name, it will load only that file. If it found the folder, all the files inside this will be loaded. All right. This is a good question from Sanjay. All right. Just give me a second. I will answer this question to you. All right. Now, this was a simple case where our data was already tab separated, slash t separated. Okay. If you open this file here, if you open this file, it will be containing tab separated data. In case your data is comma separated, you can say using pig storage. So pig storage is the class, is the function, not class, is the function which does the magic of converting the input file into records or into a data set containing various tuples. Okay, that's the role of pig storage here. If you want to load comma separate file, you can use this. Also, please note that this is not really a great CSV parser. This is not really a great CSV parser. I'm saying that because let's say if you have got a data like sen comma giri and comma 12, it will load it as sen. This is the first column, and giri as second column. All right, and the third column will be 12. Okay, first column, I mean zeroth column, first column, and second column. Okay, that's why it's not a great parser. You can use CSV parser. We will you can see look at CSV parser using CSV parser, and it will work really well. Okay, so that is one thing which you need to keep in mind. So if you want to load comma separate values right away, you can use big storage. If you want to load up many files, you can use wildcard characters like asterisk the way you did dir star dot star. In the same manner, you could use these wildcard characters. If you want to load the file from HBase, okay, instead of loading data from HDFS, okay, if you want to load data from HBase, you could use a different storage called HBase storage. In this case, it will talk to HBase and start loading data from HBase. And whenever you run anything, run any group by or anything, the MapReduce will run in HBase. HBase is a database on a Hadoop database basically. Okay, for massive scale. We will cover HBase also. If all right. Now the next thing is we can load the data by providing the column name and defining the data types. Last is that if you have to load a JSON data, you could use JSON loader. You could say things like load my JSON data type. Okay, JSON is what? JSON is a way of representing your data in JavaScript object notation. And JavaScript object notation is very popular in terms of displaying data. In terms of representing data. Okay, you have a complex objects inside objects containing array of objects. All of that can be easily represented using JSON. Almost every format. Just like XML, we can represent data in JSON, but far more cleaner and smaller. So we could use JSON loader to load the data in if data is in JSON format. Okay, and then you can process howsoever you want. So here we conclude that our pig can actually load data in a hierarchical, unstructured, and structured format. Make sense to you? All right. Next is you can see the diagnostic of any data set at any point of time using explain. You can see explain divs. So it shows you that our so far it is doing nothing other than loading and storing. Okay, it's not doing anything. If you say describe, it will show you what are the columns a data field is containing. It says there is no schema. Why? Because we have not provided the schema while loading our records. Okay, so let's say we are doing this. Now if you say describe divs, then it shows you the divs is this. You can see that everything by default is loaded as byte array. Okay, so we can see the plan, the query plan using explain, and we can see the data types definition using describe. Okay, if you are into pig and you do a lot of pig scripting, you can use the various syntax highlighting tools such as Eclipse, Emacs, TextMate, and Vim. You can download those plugins from these places and start using them. All right. So the next thing which we have already demonstrated is using storing the data. You can store the process data into a folder and then mention how do you want to store. If you say simply like this, it will store the data in tab separated format. If you say things like this, if you say using pig store and comma, it will store the data in comma separated format. All right. So by default, store, dump, and everything, anywhere we are referring file, the file is from HDFS. If you are using pig-x local, only then every reference to a file is local file system. All right. Now, when you have to print a data set, if you want to see what is inside the data set, you can simply say dump and it will print everything onto the screen. It is very useful for debugging and using the script that redirect the output. Okay, if you want to pipe the data to Unix command, you can write dump on a data set, and then you can pipe that to the Unix command. All right. The next one is, so we talked about two things so far. One is load and other is store. And third one we talked about is dump. Load, store, and dump. Before that, we talked about structure of our pig script, how to execute it. Along with that, we also talked about the data types and the schema adherence of pig. All right. Next is the for each relational operation. How would you iterate over the data? You can do it using for each. You can start basically for each is similar to select statement. If you say select star from a table, it basically gives you one record at a time. You can say select a comma b and so on. In the similar way, when you say for each divs generate something, okay, you always say for each something and generate. And in generate, you specify columns or you can put a function name here. All right. So you can basically say things like this. Divs equals to load this data and then you can say generate this. And when I say for each this data set generate these two value, it means instead of all four columns, pick only these two columns and put it in the values. Okay, and then if you dump these values, it will have only two columns, ticker and val. So Sanjay, does that answer your question? If we have an existing data in database table, do we need to convert that? No. We use specific loader. If your data is in SQL, a good way would be if you don't have a specific loader by pig libraries, you can basically move the data to HDFS and then start loading it. Or you can dump it in HBase. That's correct. Or dump in HBase. That's correct. Or use scoop to move to HDFS. Good. HDFS or HBase. Same thing actually. This is what we're talking about. Dumping in HBase. Lloyd's question is, does Pig support XML loader? Yes, it does. It does. And the name is actually XML loader. All right. You can see that while we said dump, it only gave us two columns. Okay. That is the role of for each. We will see for each is essentially a projection. It's basically for projection. What does it mean by projection? So, projection is taking one tuple and projecting or converting into another. That's what we are doing here. We took a tuple with four columns and converted into two columns. Okay, so this is basically all the tuples that are getting printed. All right. The other complex scenarios of for each are this, but before that, I think a good idea will be to take a break for 10 minutes. All right. All right, should we start now? Is everyone back? Should we start? All right. So so you could use, you know, the for each in the following manner as well. So let me just put data like this. All right. So let's say prices are this column, and under that you are trying to compute close minus open. All right. So you have NYSE daily. Let's see what is there in this file. Okay. Let me just go to slash data. And so here you see NYSE daily. You see there are these columns. Okay. Let's say we want to compute the difference between two columns. Or in this particular example, let's say we want to compute close minus open. That's all we want to. We want to compute only gain with respect to each record. So we can simply say gain equals to for each this. And when we say dump gain, and please notice a number of maps and reduces that are being generated. Okay, you can go to that URL and have a look at it. Okay, you can go here and have a look at it. Okay, whenever you are generate running these scripts. So we're basically picking up these two columns and finding the difference. If we had only, let's say we do not know their names or we don't want to refer them by names, we could also say $6 as in 0, 1, 2, 3, 4, 5, and 6. So $6 means close and $3 means open. Okay, if we have not given the column names to various fields, we could also say $6 minus $3. All right. Now, in case you want to pick up the columns starting from up to open, you can say things like this. Okay, you could say things like this. And when you say, all right, let it complete. So you could see all the columns which are starting from exchange up to open, these four columns. Can see that? If you want to pick the columns starting from open up to close, you could say open dot dot close. And if you want to pick up all the columns starting from volume up to the end, you can say this. All right. Let me ask you a few questions. Just now we talked about how to find out the difference between the two columns. So by using for each. So we said for each prices generate close minus open. Do you think when we say dump gain and there will be a map reduced job that get launched, will that map reduced job has any mapper, any reducers? Anyone? So when we say dump means it will execute the whole code. Dump is like pressing enter. Okay. So when we say gain equals for each, it is essentially defining the meaning of gain. And then when we say dump gain, then it will launch the map reduce process. Okay. Awesome. Awesome. Great. No. Brilliant. So everybody got it. Next is, yeah, this we have already talked. Yeah. All right. Next is to apply projections on the data which is very complex. Okay. Where the data types are complex. Let's have a look at something called baseball. And the baseball, I think the data is again here in this folder. Is it there? All right. All right. So the baseball data is not there. So let me just go to users, student. Let me just copy this data. Or let me just copy it to my home folder. All right. So I like to show you what does it have. So here is the file that we have been trying to get. So see, do you see this complex file? It is essentially the baseball scores of various players. The first column is the name of the player. Second column is the teams. And notice that these are separated by the tab. Then the third column is, what is this? It's a bag. Okay, it's a bag of tuples, and these tuples contain only one column. Okay, and essentially it is the characteristic of the player, whether it's a catcher or designated hitter or whatever. And then the history, the scores, various kinds of history that they have made, or the records, you can say, that it has played these many games, it has hit by pitch these many, and so on. This is a hash, is a map, while this is a bag. All right. So we are trying to load this kind of a complex data into our b-ball. You can say b-ball equals load baseball. The name is a character array, team is a character array, while traits is a bag, and batting record is a map. Now let's say we want to just pick up the batting average. All right. If you want to just pick up the batting average, we could say things like, for each b-ball, generate name and then I mean bat hash batting average. bet is the name of this particular field, and we are trying to find out only those values for this particular key called betting underscore average. Okay, for each of the records. So when we say dump avg, you will see the betting average of various players. Betting average as in for George Posada, the betting average is, you can see, do you have betting average for this? Yes, is 0.277. For this player, the batting average is, you can see here somewhere it would be there. Yeah, you can see 0.299. If you go to the end of the file, you will see that for Joel, the batting average is not mentioned. For Ben, the batting average is 0.26. Okay, so now we have just picked the batting average. Now you can easily guess that in case we want to order these player by batting average, we can order them very easily. So we have been able to extract information from a complex data type. All right. So Kanaga's question is, where is the reduce phase in Pig Latin? So reduce phase is something which Pig Latin automatically guesses. Wherever there is a need of ordering the data, wherever there is a need of grouping the data or ordering, there will be a reduce phase internally. Okay. Okay. Vidya's question is, how could you differentiate whether, okay, let me just show you how does it look like. So whether it's a bag with two tuples in each, or it's a one tuple and two fields. Okay, a bag looks like this. Will have curly brackets. Okay, two tuples of one field each. Two tuples, one field each. Right? While a tuple would look like this. Okay, like this. Make sense to you, Vidya? Now there's a question from Tushar. Question is, here is bat the alias for batting average. Bat, no, bat is the name given by us to this fourth column. And what is the fourth column? This is the fourth column. You see this map? So bat is the name of this map. Bat is a map. Alright? Fourth column. Tushar, did I make sense? Great. Alright? Alright. So here, if you have to extract information from inside tuple, you can simply say generate tuple.x and tuple.$0. If you want to do a projection on a bag, you can only pick up a particular column by using b.x. And in case you want to pick up multiple columns from a bag, you can say things like this. Instead of saying b.x comma b.y, that is also accepted. Along with that, you can say things like this. All right. Further, if you want to do complex computation, it's very much possible using for each. For example, here we are multiplying by something and giving it a name. All right. So those kind of things we can easily do using for each. And we can run multiple kind of functions, say trigonometric functions or say complex arithmetic functions. You can run those. A list of functions is available at this place. Okay, list of functions is available here. All right. Next item in pig is group by. Group by is probably the most important aspect. So if you have to group by a particular field, okay, group by meaning first order the elements by that particular key, then bring all the records for that particular keys together and form a big tuple out of it. Okay, form a big bag out of it, not tuple. So you can see that. So let's say when we dump A is basically containing these many tuples. Okay, and when we group it by age, okay, age is third column. We group it by age. You can see I've described A and B. So when we group by A, what happens is it brings these two records together, the first one and the last one. So effectively, in the end, it will be a tuple where the first record will be named as group and its value will be the one on which it has been grouped. And the second column will be a bag containing all those records for which the age is 18. Okay, you can see that. So this particular tuple and this tuple had been put into a bag. You see the curly bracket? That is the bag. It has been put into the bag and a new tuple is created in which the first column is the value on which we grouped and we have given it automatically gives it a name called group and it is second field is the bag which it has prepared. Okay, so something of this sort gets converted into something of this sort. Okay, try doing it and you will get what I'm talking about. Describe A and describe B will give you very clear picture of what I'm talking about. Yes, we can definitely write group by A and we can say $1. That's correct. You can try doing it. All right. Next is flatten. Flatten is just opposite of what group by did. Flatten basically ungroups things. So when we say, let's say this is my file. All right, this is my file and I loaded this file with this information and the next thing I did was I basically basically flattened the languages. So what will happen is it will create so many tuples where Sandeep C++, Arun Shell, Arun C, and so on. And then you can do you can do many things with this data set, such as if you want to filter it or you want to group it now based on a language. Let's say you wanted to know for C how many distinct people are there, for C++ how many distinct people are there. In those cases, you might want to group it again, but this time based on language. All right. So groups the data and flattens ungroups the data, and that's what is the role of group and filter flatten. Okay. Let's say there is a data set and you only want to pick certain records out of it. You could use filter. Filter your data set by a condition. Condition could be as simple as symbol matches cm dot star. So let's say this is our data. This is what we have the data. And right now I'll just put data here. Okay. So if you want to just pick up all the records where symbol is matching cm star, and what is symbol? The second column. Okay. So if I say dump starts with cm, so anybody knows what does it mean by this regular expression? It's a regular expression, right? What does it mean by regular expression? Yeah. What does it mean by cm dot star? Is it starting with cm dot or cm? Tusha, Ravikant? Is it starting with cm dot or only cm? No, actually, it's anything starting with cm only. I'll show you that. Let's say I write cm. You can see my text editor. Okay, so these are okay. So if I search or say something else, okay, and I say cm dot star, and here I'm going to put caret because I'm using search. Okay, caret means beginning of the line. So if I say next, you can see it is matching the first line, second line, third line, and nothing else. All right. So a regular expression cm dot start means anything that is starting with cm. Okay, not necessarily cm dot. Dot in regular expression means um, any single characters. Okay, probably most of you have not gone through my first session. Okay, here there is a complimentary session which I have provided you with the regular expression. So just go through this. It'll be probably the best crash course on regular expressions. So Vidya's question is cm star should be enough. No. Okay, and the answer you will get while reading the regular expression quickly. And all right. So here we are not dealing with files, Suresh. We are talking about the characters here in this particular field. This this divs contains these fields, and we are saying the field called symbol should match cm dot star. Okay, that's what we are trying to say. That's why you will see here CMK, CMU, CMP, CM, CME, all of these symbols have matched. Did you see that? Sanjay's question is there is something called group by and having in case of SQL. Here there is no such thing. Okay, there is only one thing called group by. All right, great. Now, in case you want to do a complex things like you want to negate a condition, you can put not before this condition. Here, this is the full condition where we are saying symbol matches something. If we want to say symbol equals this, then it will try to match it exactly with the string. Okay, and here if you put not, it becomes inverse of the condition. Next is the logical operator. If you want to say that filter divs by dividend is greater than 0.10 and is the logical operator here, and we are saying that dividend is greater than zero point 0.1 and lesser than zero point 0.2, or dividend is greater than zero point 0.4. Okay, you could put brackets here in order to make it simple. Okay, so you could use logical operators, you could use regular expression, you could use normal conditions in the filter just to pick few records out of the whole. This way you can clean the data using filter like commands. Okay, so more functions on what all could be used as condition are here. So you can see there will be a logical operator. Here you can see Boolean operators. So there are and, or, in, not. So all of these could be used without any worry. All right, in the filter. Again, I'll keep asking you these kind of questions. Will there be any reducer generated in this case? Will there be a reducer phase at all? Do you think any sorting or grouping is involved in filter? Lakshman and Suresh? So let's try to see it to just prove my point. Let's see, we are going back and here is the job which just got started. All right, let's try to say it. Do you see any reduce phase? There is no reduce phase. There is no reduce task that is getting launched. Alright. The reason is that filter can happen. If you think about if you have to do the same thing manually without using pig, what will you do? You'll basically write your map function, and in the map function itself, you'll read line by line, match it with cm dot star, and then if it is matching, then put it in the output. Otherwise, don't put, and you don't require any sorting, right? All right. Now, if you have to order a data set by a particular column, you could use order by. And the syntax is order, then data set, then by, and then the columns on which we want to sort this data set. And we can optionally put DESC in case we want to order the data in descending order. By default, it's ascending. All right. Sometimes you want to find out only the distinct rows in the input data. If we just want to find out the distinct records in the input data, we can use the distinct command. Okay, we can use a distinct function. We can say distinct my data set, and it will give us only those records which are unique. Okay, it'll compare all the records, all the fields of one record to another, and will give you the results. Okay, so my question to you is again, does the order by or distinct involve a map reduce? Will this generate the reducer side code? Yes, that is correct. Brilliant. Yes, it will generate because here whenever we do distinct, for distinct, what is the easiest way to do distinct? You have whatever records you have, you sort it, and then you go from top and keep on ignoring the duplicate records, and because if there are duplicate records they will come together, so it's easier to ignore that by just comparing with the previously read value. So you only have to retain the previous value, that's all. And you can quickly do a unique out of the records. All right. Next question to all of you is, all right, all right, there is no next question. Okay, now I'll ask the question later. So when you want to join two dataset, you can simply use the join command, which is very straightforward, and you can basically join based on multiple columns as well. If you want to join only on single column, it's pretty straightforward. You take this record, okay. Also, if you want to change the directory so that you don't have to explicitly tell the absolute location of a file, you could do that easily by doing cd. And now you can join these two data sets easily. Now you can see that the data sets are very straightforward to join. So here we are saying that join daily by symbol and with divs by symbol one. Which, what does this mean? It means the record from daily where the symbol is matching with a record in divs, both the records will be combined together to form a single tuple. Okay? Both the records will be combined together to build a single tuple. So all the records will be arranged side by side. Okay, you can see that there's so many columns now. You can see that up to here, are the values from the first data set, which is NYSE daily, and from here to here the columns are from the second data set. And what is common here? We are joining these based on this particular column. All right. If you want to join on multiple, now there's a good question from Sanjay. The join column should match the data type. When you are joining these two datasets, there should be an equality, and therefore yes. Otherwise, it will try to cast them and there could be a mistake. Otherwise, Pig will try to automatically cast one dataset with another and there will be a mistake. Next is, if you want to join two datasets, then you can basically join the two datasets by putting them in brackets. You can see that we are trying to join daily and divs on two columns, exchange and symbol, and exchange and symbol. So all those records from daily and divs will come together, for which the values of these two columns are matching identically. Okay, so this equals to this, and as well as symbol equals to symbol in both divs and daily should match. All right. Next is the self join. Self join is little tricky. So in case of pig, doing a self join requires a little bit more hard work. You cannot do a self join on a dataset directly. You have to load the same file twice and then form the two datasets, two separate dataset out of loading the same file. So you can see I'm loading divs1 exactly the way I'm loading divs2. And then I'm joining these two based on a column, and this is how the self join would work. Okay, this is how the self join would work. Or in case, so let me just delete this. Yeah, in case I want to join divs1 and divs2 based on some criteria, I could say things like this. All right. So I can do the self join by loading the same dataset twice and then considering them like two different datasets. All right. Now join should always have at least a column. Okay. Join should always have at least a column. And joins cannot have a condition. This is wrong. If you try to join A and B on A dot value greater than B dot value, this is the difference from the usual join you have learned in case of relational database. Okay. In case of relational database, if you try to join the two datasets, you could join on condition in case of relational, but here that's not possible. Can anybody tell me the reason why is it so? And why is it so that while joining two dataset, we always have to provide a column, unlike in our databases, what we did was, if we could simply say select star from table 1 comma table 2, we could do the join which was basically Cartesian product in case of RDBMS, but not here. Similarly, so can somebody help me understand why is it so? Lakshman says one reduce at a time. Interesting. Good. Any other way of portraying the same problem? All right. So yeah, Vidya says Cartesian product will result in huge data. All right. All right. And okay. So the main reason is that when we are joining here, when we are joining two data sets, we are essentially using MapReduce, right? And when we are doing MapReduce, what exactly we have to do in MapReduce? We have to define a key, and based on the key, the two records are sort of pivoted, or you can say grouped together, and that's what is happening. Therefore, every MapReduce need to have something like map phase need to define a key if it wants to group the data, right? And hence it always needs a column. Also, since it's using MapReduce to group the records, it doesn't make sense for using the condition to group, because based on the condition we may not be able to generate the key, and hence we cannot join the two records based on the key. Correct. That is correct, Vidya. So you got it correctly. Yeah. So let me repeat Vidya's point. So it needs at least one column, and the condition is not checked. Basically, it concatenates the two files like voter example. So that it is doing in the similar pattern, in the similar way. Good. Yes. All right. Now let me try to give you a visual representation of what's happening in the case of joining. Let's say there is a table A which has two columns called ID and name, and there is a table called B that also has ID and surname. Okay? And now what we are doing is we are saying join A by ID and B by ID and dump LO. Okay, so it will give me one Sandeep, one Giri because ID is same both the sides. And here there is no 2 on the right hand side and there is no 3 on the left hand side. And effectively there is only single record which it has resulted. Alright. So this is the normal inner join. Clear? So we are joining on ID. Is this clear to everyone? If there is a doubt, please let me know because the ones which are coming up are a little more complex. Yeah, this is equijoin. Thank you, Sanjay. Is it clear to everyone? Should I proceed? Great. So let me proceed then. If you are comfortable with this, now there is something called left outer join or outer joins. Okay, so there are two kinds of outer joins. One is left and other is right. So in case of left, when we say join A by ID left outer, okay, comma B by ID, so we are trying to join A and B in a left outer manner. What does it mean by left outer? Left outer means that all the values from the left will go in the output irrespective of whether there is a value on the right hand side or not. If there is a value on the right hand side, well and good. Otherwise it will just put null or the blank at that point. Okay, so if you can see that here one Sandeep has got a counterpart this side, one Giri, but for two Ryan there is nothing, so it is blank. This is left outer join. Or simply, you could also say left instead of saying left outer. Alright. Similarly, right outer join. In case of right outer join, all the values from the right hand side would go in the output. You can see 1 Giri, 3 Shaha, and there is no value with respect to 3 Shaha on the left hand side, and therefore there are blanks. So this is very much similar to SQL. Alright. Or instead of saying right outer, you could also say right. Okay, the way you said left outer or left, they're both equivalent. Now a little bit teaser for you. So what will be the result in this case? Anyone? So 1 Sandeep and 4 Ryan, 4 Giri and 3 Saha. If I say write out a join of A by ID and B by ID, what would be the result? Anyone? Quickly. That's correct. It will be 4 Ryan, 4 Giri. Here, 4 Ryan, 4 Giri. And 3 Saha has no counterpart on the left hand side. Alright? Good. Good. Good Suresh. Good Savnan. Good Sandeep Mane. Great. Alright. Oh, you did, Tushar did a left sign. Okay, okay. Now it makes sense, yes. So in case of left sign, your answer is correct. Good. All right, moving ahead. All right. There is something called full join. Full join as in equijoin plus left join plus right join. So you can see here. So for one, whatever value has found on the both hand side, that goes in the output. In and for left hand side, whatever the values from the left hand side, there is no counterpart on the right hand side, that goes in the output and the right hand side. This is full join. Is it clear? What does it mean by full join? Because there's a question coming up. So first intersection of both the sides, then all those values from the left hand side for which there is nothing on the right hand side, and all those values from the right hand side for which there is nothing from the left hand side. Okay, so that is full join. Clear? Now question to all of you is that if if the inner join gave us n1 records and left join gave us n2 records and right join gave us n3 records, how many records will full join give us? Anyone? The inner join, where we said join A by ID, B by ID is n1 records. Okay, total number of records we are counting. So question is, how many records will full join give in terms of n1, n2 and n3? Lakshman, are you sure? So your results are irrespective of n1? So I've got only one correct answer so far, and the correct answer is from Richard. Good. Ravikant has also got the correct answer. All right, you are little off, Ravikant. Okay, okay. Yes. All right. Anyone else? Yes. Tushar also got it right. Great. Thank you, Sanjay. Anyone else? Good. Keep going. So, Tushar, Sanjay, Richard have got the right answer. And Ravikant, you are just on the verge. If you could again, just express it. I think you have misplaced N1, N2, N3. No, it's not N4. It has to be in terms of N1, N2, N3. That was actually funny. So yeah. All right. It is N2 plus N3 minus N1. And how is it so? So basically, we say that intersection plus all the records which are there on the left hand side, which is N2 minus N1, only the records from left hand side, and then plus N3 minus N1. Okay, equals to this. Okay, because N2 contains the common records as well, so we remove the common records. N3 also contains records from the right hand side plus common records, so we remove that. So only the records only from the right hand side are these many, only from left hand side are these many, and the common are these many, and therefore our answer is N2 plus N3 minus N1. Yes, great, Lloyd. Thank you. Right. Now you got it right, Ravikant. Great, great, brilliant. All right. Now, so few teasers. Don't okay. Don't lose your cool here. If we have A and B, and we are saying join A by ID, B by ID, left outer, what will be the result? Quickly, anyone? Mind, I mean, keep in mind that it's a teaser. Okay, okay, all right. Let me make you mad. The result is that it's a syntax error. The left or right keyword has to come just before comma in the middle. Yes, that's correct, Sandeep. Yeah. All right. All right. Now, now the next one is I'm saying join A by ID outer, comma B by ID. What will be the result? Correct. It's a it's a error. It's a syntax error. That's correct. Great. It's a syntax error. All right. So you could basically limit or sample as well. You could basically limit or sample as well. Say if you want to pick only first 10 record, you could say limit divs 10 and it'll give you only the first 10 records. If you want to pick randomly a percentage of the input data, you could use sample. For example, if you want to pick point say 10% of the records, you will say point 0.1. Okay, sample divs point 0.1. All right. If we had to pick If we had to pick only 1% of the data, what will I use here instead of this? Sum equals to sample divs. What will I use if I have to pick 1% of the data? Anyone? Correct. I'll use 0.01. Good. Now, so basically, here in the statistical sense, this sample function makes a lot of difference because this kind of construct was not available in the usual SQL because in the usual SQL this was not really much required. Okay. Here, in case of big data, whenever you are churning the data, so before you start churning, what you do is you at least prepare a sample out of big data. Instead of just working on 10 record, first 10 record, last 10 record, or any such thing, you pick records by sampling so that whatever SQL you build, it gets tested on the records from across the data set rather than only the tail or the head. Alright? Yes. Sample randomizes the data pool. So every time you sample the data, you will get different results. So Ravikant's question is sampling completely random? That's a very difficult question to ask. And if you ask a mathematician, even they cannot say yes. So I mean every random number in case of computing is called pseudo random. Okay. And there's an ongoing, I mean, every now and then people keep on coming with a random definition. So it is dependent on the Java library of random number generation, and that's fairly stable. So it's sort of good, random in a good way. All right. Yes, you can kill the job from here. That is Sandeep's question. You can kill the job the from the command prompt here. You can say kill and the job number. Okay. So if you say we started some process dump and parallelly you could open the pig command prompt in another terminal and kill this job ID. You see the job application number here. Here you can see this one. You can kill the job ID. Okay. Let me just go back here and open another pig. Okay, I have started another pig. I stopped the previous pig script by pressing Ctrl Z and I can say kill this. Alright, I think this is how it happens. So what does it say? Error during parsing encountered this line here. Alright, let me try to understand. Help kill. Kill the Hadoop job ID specified by Hadoop job ID. Yeah, this is how it works, right? What does it require? Oh, it needed job underscore that. Now it has been killed. See that? It has been killed. But it has already succeeded by the time we tried to kill it. Now I can do FG and bring back the command prompt. Right? Good. Alright, here is another question for you. So what am I doing is I'm saying div equals to load tab separated file, and I'm saying sum equals to sample divs, pick up 10% records, and then I'm typing dump sum twice. Okay, do you think it will lead to different result or the same result? Dump sum will give the same result, the two twice, or the results will be different. Sanjay, same or different? Okay, so Sanjay says no, which means it will not give the same output. All right. Tushar says not same, different, no, different. Brilliant, brilliant. That's correct. And those, the reason is the actual processing starts when you say dump, which means you say dump and then it goes back and loads the file and then creates sample. You again says dump, it again goes back and loads file and do sample. And since sampling is random, every time the process is repeated, it will lead to different result. The most important part here to understand is the actual processing starts when you say dump. If you say dump twice, then the actual processing will start twice. Okay? And therefore the result will be different. Alright? So that's why I'm saying most likely no. If you are really, really lucky, there are chances that it will lead to the same results. I'm trying to be politically correct here. There could be one very specific case where it could lead to the same result if you are really, really lucky. Right? So up to here, do you have any questions? Yes, that's like hitting a lottery. Thank you, Lloyd. Yeah, good. Now, the way in case of MapReduce, we were specifying number of reducers. Same thing we can do in case of pig as well by specifying something called parallel keyword. Okay, we could specify number of reducers by saying parallel x, which means x number of reducers. So parallel keyword controls how many reducers are there. Okay, and it does not impact the mapper's behavior. Okay, it does not impact the mapper's behavior, and the you cannot create total number of reducers beyond a certain 99,999, I think. So okay, let me explain again. So parallel keyword defines how many reducers do you want. Okay, almost after every statement you can say parallel 10, parallel 5, whatever how many reducer you want. Okay, if you put parallel keyword with a statement which does not have number of reducers, it will have no impact at all. Sometimes you want to apply the parallel statement globally for the whole script. You can do that by executing a statement called set default and default underscore parallel and 10, which means every every statement which involves reducer will have 10 reducers. Okay, 10 reduce tasks. Without parallel, okay, without parallel, pig automatically decides on number of reducers. How does it decide on how many reducer does it need to create? Okay, so it basically creates one reducer per gigabyte of input data. So if your word count file is 2 gigabyte, automatically it will have two reducers. That's how it does. Okay, it tries to behave a little bit clever by putting one reducer per gigabyte of data. Also also the strategy is that in case you have got 1 terabyte data, still the number of reducers will not go beyond 999. So if you have got 999 GB of data, then you will have 999 reducers. If you have got say 1100 GB of data, still the number of reducers will be 999. Okay, so that's the behavior and that's the way Hadoop pig decides to keep the number of reducers. Sanjay's question is, why would they name it pig? All right, so there's a culture in open source world to create the tools after pig. Okay, and since Hadoop was named after an animal, so in the same way they also named it pig. Okay, exact reason I don't know. All right, now how many reducers will it produce? For each divs generate symbol divs stop and divs into 10, which I think we have discussed it already. Okay, it'll have zero reducers. Okay, because there are no order by or group by, and therefore do you think there will be any impact of parallel clause in this? If we put parallel 10, will it have any impact? So no, because the parallel keyword only has impact on on the scenarios where our reducers are involved. All right, good, good. Everybody okay so far? Sometimes you find out that you do not have a function for a particular thing in pig. In those cases you want to call an external function. Okay, so you can do that. And pig's basic premise was pigs are domestic animals, meaning pig pigs can pig are controllable, as in you can customize pig, right? And therefore it is possible from pig to call any external function. For example, let's say you realize that you want to convert an integer into hexadecimal string. For that you do not have a function in pig. So what would you do in these cases? You can define you can invoke a Java function from within pig. So there is a static function called toHex string in the class called integer. So here we are saying that we're creating a function called hex, which basically will invoke integer.toString and and will return a string out of it, and it will pass the argument as integer. So once you have defined such a function, then you can basically use this function inside for each. Okay, so basically every time we call hex, it is going to call Java's inbuilt function to convert integer into hexadecimal number by passing the integer here in the argument. All right. Sometimes you want to write your own. Yes, the external functions will be map reduced. So if you look at this way, what would happen is the library will be called in the map phase here. Okay, this hexadecimal function will be called inside the map phase again and again. All right. All right. Sometimes you want to create your own Java function that you can do very simply by registering your jar file and defining your function and calling that inside here. Okay, so we are saying convert means this particular class. Okay, and this we are basically calling the constructor here, and then we are calling the convert function. Okay, we will demonstrate to you how to create your UDF. We call them user defined functions. Also, if you have a Python program called say production.py, then you can use that inside your pig script. So python.py contains say 10 functions. All those 10 functions will become visible here. We are saying register production.py as bball. Okay, as bball using something called a Jython. Jython is Java Python. Okay, it's a library which makes it possible to call Python function from within Java. Okay, so here we are saying that register this as bball, and out of the bball we are calling one particular function called produce. Okay, similarly we can call other functions of produce by passing these values, and we can utilize any Python library in this manner. So we talked about three things on this page. First, calling the inbuilt Java function from the standard library. Second, creating your own Java function. We will go into the detail after this. And third is calling the Python function, calling any of the Python functions listed in your Python script. Okay, so this is how you can call external functions. Let's try to create our own user defined function. So if you are interested, you can download this project. Ideally you should do it as soon as you get time. So you can download this project and unzip it. uh, so you can download right away and unzip it and import the project into your Eclipse. Okay, all the libraries whatever is required would be there already configured. All right, is everyone with me? All right. Lloyd's question is, where do we store the jar file before registering it? It should be in the folder from where you have started the pig. And this jar file should be in the local directory, not in HDFS. Okay. If the external function fails, how is the exception handled? It will be displayed in your error log. Okay. It will be displayed in the error log. Alright, let me try to show you. Alright, so here is my pig UDF. There are few things which you should pay attention to it. Alright, let me just close it. Yep. Here, all I've done is created a function called upper. To create a function called upper, I had to create a class called upper here. Okay, to create a function called upper in pig, I had to create a class called upper here, which extends eval function and for a data type called string. Okay, it basically returns this upper function will be returning a string and will be accepting a tuple as input. As we were telling you about, every data set is made up of tuples. Okay, so by default, every exec function takes tuple as input, and now it's up to the exec function whether to convert this tuple into something or to operate upon a tuple. So here what we are saying is pick up the zeroth value from the tuple and convert that to uppercase. If it doesn't have zeroth element, then return null. Otherwise, otherwise you give the error. Okay. So does it make sense, Sanjay? You were asking about the exceptions thrown by the external class. Okay. Now once you're done with this, what you can do is you can simply say right click on pig UDF and say export, select it, the jar file, click next, and then let me just give it a name. I'm giving it a name called pig udf.jar and export. So it has been exported. All right. Now I'm going to copy it. You could also use the browser, and then you can use you can upload it into HDFS and download it locally. But here going to copy it into Hadoop 17 at Hadoop 3.nobigdata.com colon sgiri underscore, I don't know what is the folder name. All right. So here, let me just copy the password. What did I do wrong? All right. So it's saying SCP, and we have not provided the folder input file, and it was pig udf.jar. That's what we did, right? We said file export. Just give me one more minute and pig udf.jar, and we are copying it there. All right. So here, if you say, if you, so under sgiri 3, all right. So now what you can do is go into the script and say register pig udf.jar. We'll have to say register, and let me exit from it. So this is the folder from which we are starting. So our file has to be in this folder from where we have started. Okay. And say, then we can say, so it has successfully registered your jar. Okay. Now we can change the directory to something in HDFS and load this particular data. And then for each, you could just dump the data. It'll not be able to find the data most likely because I don't think it is there. Yeah, it was not able to find the data. All right, let me try to do it again. because I'm not sure where this file is located. Somewhere not here. So let me just try to ls/data. So is it there somewhere? Yeah, it is there. So we could say slash data, yeah, and dump B. Now it will convert it into uppercase. Were we doing uppercase? Yes, we were doing uppercase. All right, let it do the job. So in the meantime, let's have a look at what we are trying to do. We are trying to basically we registered pig udf.jar, the jar which we just created by exporting our project, and then we went into the data and let me clean it up. Okay, and then we iterated over the records here and generated the uppercase of a particular value. Okay, so you can see that it has converted into uppercase here. All right, you can check what actually it has done by printing the actual value of the file. You can see that it has converted that into uppercase using our class. All right, so here as soon as we have registered here, so what is this myudf? Myudf is the package of our class. Okay, all right, thank you very much, and we'll continue from here. But please note that all the assignment of pig udf, you should go through it. Okay, we will be fixing this. We have actually expanded a little bit more. So the assignment is in the session 6. Okay, so we'll be fixing this problem because it was supposed to be done on September 13. All right, so we'll fix this in the LMS. All right, please finish this two assignment. One is subjective quiz and the objective quiz. So please finish this. All right. So you should be able to, based on what we have learned today, you should be able to finish both the assignments. Okay. All right. Thank you very much. See you on the next week. See you in the next week. Bye bye. Have a great day. Thank you, Jesse. So I'm assuming that you guys are finding Pig UDF easier. I mean, Pig Latin and Pig in general easier than MapReduce. All right. Thank you, Suresh. Have a nice week ahead. Bye bye. Great, great. Thank you, Tushar. Thank you, Lloyd. Thank you, Suresh. Thank you, Ravikant. Thank you, Jasi. Bye. Have a great week ahead. Thank you.